Hey guys, welcome back to my channel. In this video, we'll be talking about coplanar non-concurrent forces, moment of force, and some examples related to that. So, what is a coplanar non-concurrent forces? It is nothing but if all the forces are acting in the same plane, but the line of action of all the forces do not pass through a single point, then that kind of system is called coplanar non-concurrent forces. So here we have, now let us talk about moment of force. Moment of force about a point is the measure of its rotational effect. Moment is defined as the product of magnitude of force and the perpendicular distance of the point from the line of action. The point about which the moment is considered is called the moment center. The perpendicular distance of the point from the line of action of the force is called the moment area. So the perpendicular distance of sorry, one second. From the line of action of the force is called moment area. The unit of moment is Newton meter. So here we have force like this, and this is the point of application, and this is the arm of the force, that means the perpendicular distance. So moment will be equal to force into OB, that is this. So it is nothing but if the force is in this way, then the distance will be actually perpendicular to it. Like in this case, it will be like this. Okay. So we need to calculate that distance. So force into OB, which is OA sine theta. That is, if you are considering this as theta, then this will be OA sine theta. F into OA sine theta. So, moment of force will be maximum when the line of action is perpendicular, because if it is perpendicular, uh, theta will be 90 degree, then sine 90 will be equal to 1. So it is saying that a moment of force will be maximum when the angle between the force and the line of action is 90 degree. Moment of force will be zero when the moment lies on the line of action of the force, because in that case the theta will be equal to 0, and it will be obviously it will be 0. The moment of force has got direction. It can be clockwise or anti-clockwise. So in this case we have an example here. We need to find the moment of 100 Newton of force acting at B about a point A as shown in figure. So this is our figure. This is AB, and here we have a 60-degree angle like this. And here we are given measurements of 500 millimeter and 400 mm. Okay. So if you are given something like this, what we will do here is that for finding the moment of 100 unit of force, we need to multiply that force into two. We need to convert that force into two directions. Why we are doing this is because if we are having this force in this direction, actually it is not in this same direction. There is a mistake here. Actually 60-degree won't be like this, it will be somewhere around here like this. One second. It will be somewhere something like this force will be something like this. And if you resolve this forces into horizontal and vertical, then this force, Fy force, multiplied by the 400 Newton, okay, will give the moment on that side, and Fx into 500 will give the moment on that side. So if you are taking this force as 100 Newton, 100 cos 60 is equal to Fx. So it is minus 100 cos 60 into 500. Okay, because we are going in the clockwise direction. and in this case it will be plus 100 sine 60 because we are going in the anti-clockwise direction. So that is important. The direction in which we are rotating is also important. So we are getting 9641.06 Newton meter, and it is anti-clockwise. Why? Because it is positive value, so it will always be anti-clockwise. Here we have another example. We need to find the moment of force about A. So this is our point here, A, and here we have forces like 10 Newton acting downwards. Then we have 50 Newton like this. Then we have 20 Newton like this. Okay, so what do? We know that moment of force is nothing but the force multiplied by the perpendicular distance, and in this case it will be 10 into 2, but the sign will be negative because it's in the clockwise direction. Clockwise is nothing but in this manner, the way how a clock runs. The clock hand will always move in a clockwise direction. So they are saying here that if the force and the perpendicular distance plane of action moves in a clockwise direction, the moment will always be negative. And here we have 15 Newton force in the anti-clockwise direction, so it will be 15 into 4, and the other case also minus 20 into 6 because it's a clockwise direction. So all of this will give us the moment of inertia about A, this point A. So it is minus 80 Newton meter. Why? Because minus 20 minus 60 minus 120 is minus 140. 140 plus 60 will give minus 80 Newton meter. So it's minus 80 Newton meter. Actually it should be clockwise because it is negative. Actually it's clockwise. Okay, now now let us talk about Varignon's theorem. Varignon's theorem states that the moment of force about any axis is equal to the algebraic sum of the moments of its component about the same axis. We have already dealt about this in the earlier cases, but in this case we should understand that there will be a force for the resultant also. If you are taking the resultant of all the forces and if we multiply it by the perpendicular distance, it will be equal to the algebraic sum of the individual forces and distances. So there are some points to be noted here also. That is that if a system of coplanar forces have a single force as their resultant, then the algebraic sum of the moments of the forces about any point on the line of action of the resultant is zero. They are saying that if the if you are having the resultant and it is lying in the line of action of the res- forces, then it will always be zero. The principle of moment states that the moment of the resultant of a number of forces about any point is equal to the algebraic sum of the moments of all the forces of the system about the same point. Okay, algebraic sum of all the moments of all the forces of the system about the same point. It's just saying the same thing. Okay, so in this example we need to calculate the moment of force 10 kilonewton acting at a point A as shown in figure when the angles theta is equal to 0, theta is equal to 30, theta is equal to 90, and we need to calculate the maximum moment of force about A. So this is our force which is acting in this direction. Okay, and this is our point A. Okay. Now, in the case when f is equal to theta is equal to 0, what will happen is that when theta like this, if the force is in this manner, we can just take this in this side. Okay, we are just moving that force in this side. Now, mm, the line of action here is horizontal. Hence, arm of force here is will be 2.5. So moment of inertia about O is equal to 10 into 2.5, which is 25 kilonewton, and it is anti-clockwise. And in the case when theta is equal to 30 degree, so if theta is equal to 30 degree, it will be somewhat like this. So in that case, the line of action passes through the moment center, because in this case this is the line of action and it passes through the same line of action. So the moment will be equal to 0. Okay. Now if theta is equal to 90 degree, that means if the force is something like this, once again, something like this, that means we can draw it in this manner. Okay, so we can move that here. So it will be 10 into 4.33. So we'll get 43.33 kilonewton. And in this case, it will be clockwise. So it will be negative. So moment is maximum when it is perpendicular to OA. That is, if it is perpendicular to OA, then only it will be maximum. If it is perpendicular to OA, that means uh, it will be like this. I'll just draw. If the force is like this, then it will be 10 into 5, which will be 50 kilonewton. So it will be the maximum. So they are saying that when the line of action and the moment and the force are perpendicular to each other, the moment will be maximum, and if they are parallel, it will be the minimum. Now in the second case, we need to calculate the moment of the force system shown in the figure about O. So this point here is O. Okay, so here we need to find the moment of force system shown in figure about O. First of all, we need to resolve these forces into horizontal and vertical forces. Okay, so we'll get 31.785 Newton on the horizontal axis. So we'll just draw that. So our horizontal resultant force is 31.785 and vertical force is minus 10.44 Newton. So as this horizontal force is on the line of action of O, we can say that it will be 0. And in the case of this, it will be it is perpendicular to O. So in that case, it will be minus 10.44 into 5, because it is the distance between that. Okay. Now let us move to the next one. So we are ending our session at here because the next we'll be talking about resultant of coplanar non-concurrent force system. So we'll be doing that in the next session. So I hope you understood what I have taught you till now. If you have any doubts, please let me know. You can comment me or you can email me. And if you are enjoying watching my videos, please consider liking my videos and sharing it. Thank you for watching. I'll see you in the next one.